Right, to take it one step further again, Chris Wrigley reporting on Safer-Gro. We're now doing a tour of the facilities in that we are looking where the raw material comes in and actually following that through to the packaging end of things. I'm keeping a very tight hold on my little beaker of glass beads because I'm interested to see where these fit in the process. But John, as far as I'm concerned, this looks like one big Magimix, something that my wife uses when she's making the batter in terms of Yorkshire pudding.
That's more or less what it is.
Right.
What happens is we have a mixture of surfactants, a pump from a vessel next door into this vessel, and then the introduction of powder via the screw feed Flexicon into that vessel, and under very high shear, under high speed mixing, is incorporated into the surfactant mix.
Yeah.
And then once that's done, it's sent through another colloid mill through further on into the process.
Am I getting closer to looking at where my glass beads come in?
Nearly.
Okay.
In a while.
Okay. Now I guess at the moment, between each batches of material, you have to go through a clean down process because contamination is something you don't want.
At the end of a campaign, we clean down, and depending on what the subsequent product's going to be, our clean down can vary from 1,000 ppm down to 1 ppm.
Okay, so we've got water, powder, mixes through, produces a slurry, then disappears from this vessel, and that's some electric motor you've got there. Don't send me the bill, will you?
No, 45 kilowatt.
Oh, so let's go and have a look next where it goes.
It then comes into this vessel.
As a slurry.
Yeah, and that's a holding vessel that feeds our bead mills.
Yeah.
We're getting close.
Getting close to my glass beads.
Yes.
Yeah.
From here it's pumped downstairs to the bead mills and then re-emerges in these two vessels.
Right.
At the end.
Okay. Are these vessels filled before the bead mills or after?
These are the result of coming out of the bead mill.
I'm with you. Right, okay.
So we have two finishing vessels, and once these have reached the required quantity, we add any other further components, such as a gelling agent or preservatives or anything else.
Right, okay. So we're getting very close to the finished product when it leaves these vessels.
So when we've added any further components, it becomes the finished product, then it goes off to the laboratory for testing.
I see. So it's tested before any packaging, John?
Certainly.
Right, okay.
And this, you can see that's the finished product now being stirred.
I'm with you. That's quite a rapid stirring motion, isn't it?
It needs to. You've got 5 ton here, you've got 6 ton here, so you need pretty good stirrers to stir it all up and incorporate all the components. Right,
okay. Electric motor's just a little bit smaller, but still don't send me the bill, please. Right. So where we're going now, John? We'll go
downstairs.
Right.
And have a look at the bead mill.
Oh, good, good. So I'm assuming now, John, this is the bead mills. This is where I've been hanging on to this for. Right, okay. Just explain this to me then, and where these tiny little beads come in.
These beads are within this cylinder. This cylinder is jacketed. It has a coolant solution going around it because the amount of work that we do on the slurry, on the powder to grind it down to the particle size required, generates a lot of heat.
Yeah.
So we have to take that heat away.
So hence the condensation on this. Yeah, okay.
This starts out at about 0 degrees.
Right.
And will go up to about 25, 30 degrees.
So the speed of the balls revolving and the material generates just like just a thermal heat. It's friction, I guess, isn't it? Yeah.
The speed of the balls going round, the tip speed of the rotator is 17 metres per second, so it's quite quick. The beads, there'll be, in this mill, there'll be about 314 kilos of those beads in that mill.
In here, yeah, yeah.
So the product goes in this end, far end, comes out into the vessel that we saw upstairs.
Right, okay, so it goes into here in slurry form,
yeah,
and then the action of these beads reduce the particle size, gets to this end after a set time in there depending on the requirement.
Flow rate.
Okay, and then out of here.
Out the other end.
Oh, I'm glad to see where these fit now.
So the particle size is about 2 micron.
Yeah, that is small.
Yeah, and these beads, the action of them grinding down gets smaller and smaller, and eventually we have to change them.
What's the sort of intermittent time change then for these?
It depends on the materials that we're putting through,
Yeah.
but 5-6 months.
Oh right, that long?
Yeah.
Yeah. Oh, interesting. So okay, that's where the material particle size gets reduced, and then I guess on to the next level where we see some packaging taking place. Okay, I suppose you're going through a certain amount of engineering works. You have to clean down, you have to repair, you have to renew.
That's what we're doing at the moment.
So that's a constant thing, isn't it?
Oh yeah.
So you've got your own team of engineers and...
Yes.
Yeah, okay. Okay. So this is the packaging, where the label goes on, the batch number and all that sort of thing.
Yes, it is. The packing and capping is done within that filling zone there.
Right.
And they'll emerge. At the start we've got a cap detector, and then what happens is it goes under here to seal the cap, just like a milk bottle.
Okay. Is that done by heat?
It's done by an induction coil, induction loop.
Right, okay.
And what we have is, so we have an induction seal where it's sealed up, so it's...
Oh, I'm with you. Yeah, okay.
So it's
a bit like a milk carton in a way, you just have to tear that off, right, okay. Yeah.
We'll take that off and then use it.
Okay.
Now this is a 10 litre pack, it's the biggest pack we'll send down this line.
Yeah. Okay.
It goes along. If we're putting labels on, it'll have labels back and front if need be. And if we really want, we have cap labels. Some of our customers like cap labels.
Okay, I'm with you.
And then on here it receives a batch code. Here with the date of manufacture.
Right, and that's from your point of view, that's so that the grower knows what batch this has come from. From your point of view, again, that could be traced back to that batch.
Correct.
So this is again traceability.
So with this batch number, we can trace backwards to find out what raw materials went in it.
I'm with you.
And conversely, if we looked at raw materials batch number, we can find out what product it went into.
It's interesting, this batch number then is actually inkjet sprayed.
Yes.
And as it passes this inkjet sprayer, that's...
Yeah.
Yeah.
You have a magic eye.
Yeah.
And then it just, on every bottle.
It's fairly unique.
And then it goes into the carton, and each carton has a batch code, and then back on pallet and out the door.
Okay, okay. So this is how I see it when it's delivered to our chemical store or a customer's chemical store.
Yeah.
Yeah.
And throughout the whole process we have QC checks, in-process checks to make sure that the cap is sealing, the induction seal is okay, batch coding is okay, the fill weights are, because you don't want to be shortchanged of...
No, I don't. No, thank you.
We assure that...
So you'll just take at random one of these 10 litres, take it to the QC lab and do the relevant tests?
We'll do tests, and this is where we keep a sample. We get the sample from off the line, not from the production area, off the line, so it's representative of what the customer sees.
Right.
So if we have any issues, we've got a sample of what the customer
Okay, okay. Interesting. Okay, John, so this is, I recognise this is ready for distribution now.
Certainly is.
Packed, nice clean packaging, shrink wrapped. What sort of legislation do you have to adhere to here? Because it seems fairly stable and...
Well, you need to ensure that when it gets to its destination, that it hasn't fallen off the pallet, basically.
Right, okay.
You don't want to receive damaged goods.
Yeah.
The lorry doesn't want to clean out the back of his unit.
Yeah.
So we try and make sure that...
Is this all batch marked? Is this batch numbered, the whole pallet?
Yes. Each individual carton's batch coded. The pallet has a batch code on it. It's got a pallet card detailing what it is, the amount and the batch code.
Okay. One plea for help, and that is that clear labelling is absolutely critical to the end user, the spray operator. And so many labels these days look the same. So it's not beyond the realms of possibility for him to grab a bottle of something that shouldn't be going in the tank purely because the label can't be identified easily.
Right.
He's in a rush, he's in a hurry, grab a bottle, in it goes, and it could end up desiccating the crop.
Yeah,
so
especially if he's saying, I want some magnesium, and he gets the manganese or something like that.
Yeah, it could
so
be
what
something
we do
else.
is, apart from the obvious labelling, the colour coding on the labels helps to distinguish between the different products.
Alright, so you're going to colour code each product.
Yes.
As long as nobody's colourblind, make the manganese big in big bold writing.
Correct.
And the magnesium. It'll just eliminate as many problems as you can.
Yeah.
So there we go. That's the end of the trip round the factory. A couple of things that I picked up on. One, apart from the interest from my point of view, and I can bring this back to my growers, the environment in here is far better than I ever expected in terms of odours. It's far better in terms of cleanliness. Every available safety legislation is adhered to, batch numbers all the way through the process. So that ticks another couple of boxes as far as I'm concerned. And John, thank you very much for your time.
No problem.
Enjoyed it.
Thank you.